So we got another question, a rare question on CAPM. And this is a question that you may see on your exam, and it's definitely one that could throw you off because it mixes a little bit of what you learned from chapter 8, which is portfolio theory, and what you learned in chapter 9, which is the capital asset pricing model. Now, hopefully we'll be able to walk through this together and you'll feel empowered to solve this on your exam if you're ever to face this Goliath. Now, before we proceed, make sure you get your formula sheet. I think it's the best practice here. You always want to be able to, because this is what you're going to use on your exam, right? Assuming that you're allowed to have a formula sheet or that they give you one, it's really good to kind of get a sense of, okay, this is what we need to look for in an exam question. And you'll have it in front of you. And then it's just a question of looking through the prompt and just identifying the little pieces, the little parameters that are actually part of your formula. And then it becomes a real simple puzzle, okay? A real, like, not a bad puzzle, like you're literally solving for one missing piece of the puzzle. It's like as easy as that. Anyways, I'm not gonna try to convince you about the benefits of always having your formula sheet with you and always like writing the formula at the top of your paper. You'll see how I go about it, and hopefully you can kind of learn and use that when you study for your exam and your finals and all that good stuff. So let's get into it together and we'll identify stuff step by step. This question is awesome because we're dealing with Adam Sandler. Imagine we're dealing with Adam Sandler's portfolio. He entrusted us with his portfolio. That's pretty awesome. And his portfolio right now has an expected return of 15.28%. Okay. And his portfolio has invested 60% of its wealth in Meta Platforms Inc., also known as Facebook back in the days, and the rest has been invested in Apple stock. Okay, so already there, we're giving you some pretty valuable information. We're telling you a few things. We're telling you, hey, the expected return on Adam Sandler's portfolio, so we're going to write it like this, is equal to 15.28%. And 28 is such an awesome number. And his portfolio invests a portion of it in, we're going to call it asset A, so Facebook or Meta Platforms. We're going to call it as the weight invested in A is equal to 60%. Okay, and so far it seems like Adam Sandler decided to only invest in two stocks: Meta Platforms, known as Facebook, or Apple's stock. Okay, so we only have two portfolios, and by definition, if we only have two portfolios, the rest of the portfolio will be invested in Apple. So if we were invested, we call Apple B, if we were invested at 60% for weight A, by definition, we'll be invested at 40% for weight B, so for the second asset. Now, we're also letting you know that the risk-free rate of return is equal to 2.8%. All right, so RF is equal to 2.8%. That's awesome stuff. And the market risk premium, okay, is equal to 2.75%. I mean, wow, I'm lost. 6.75%, my bad. But the market risk premium is equal to 6.75%. So we're telling you that ERM minus RF is equal to 6.75%. This should be clear to you if you just understand what the formula, really stands for, the SML formula. And now we're going to highlight the mission. What's the purpose of this question? The purpose of this question is to solve for the reward per unit of systematic risk. Anyways, if you've never heard about that before, you're going to be like, what the hell did you just write on my exam? You're going to be confused. But there's actually a really easy way to go about that. It's really not that complicated. And we're going to talk about what is the reward per unit of systematic risk for Meta Platforms Inc. if the beta of Apple, okay, is 1.17. This is getting strange, all right? We're talking about expected returns, we're talking about a bunch of stuff, but also we're talking about beta. So what are we going to do with that? So we know that the beta of Apple, so I guess we're going to call it the beta of B, just to be like very, concise here, is 1.17. Okay, so we're going to try to work through this. We're going to try to make sense of this because we want the reward per unit of systematic risk for Meta Platforms Inc. All right, that's what we want. So we want the reward per unit of systematic risk for asset A. Before we proceed, I'm just going to take a second to define, just to be very clear that everybody knows what this means. What the heck is systematic risk? Systematic risk can be coined by the term beta, okay? So just remember that this means beta. So we want to know, what is your expected return per unit of beta? So in other words, you're just going to take the expected return minus the risk-free rate over beta. It's something that we're going to look at, and it's a little bit more in detail afterwards. Okay. Now in this question, because we're dealing with a portfolio and we're also dealing with this notion of beta and the risk-free rate and the market risk premium, there are really two formulas that we want to highlight. Okay. We're going to write them at the top, I guess, in blue. The first formula that we care about is the formula for the SML, which is going to be K is equal to RF plus beta times the market risk premium. Look at that. We have a lot of this information already. The second formula will be a very straightforward formula, which will simply be that the expected return of a portfolio is equal to the weight of A times the expected return of A plus the weight of B times the expected return of B. The reason why I'm saying this is because, of course, if we're invested into two different assets, we can simply write it as being, written like that. It's pretty straightforward. But still, it's kind of confusing. We're like, okay, we have a bunch of information, and I guess we'll highlight them on our formulas because that's always what you should do. And then we're going to solve for the missing variable. But like, still, we're not too sure where to go with this. So that's why it's so important to write the formulas, the only formulas we can use here, and then just solve for the missing piece of the puzzle. In this case, we know that, okay, the ERP is 15.28%. So we could go ahead in our formula and like highlight that. We also know that the weight of A is equal to 60% and the weight of B is equal to 40%. So, I mean, so far, not so bad. It's going okay. And then for the risk-free rate of return, we know that that's equal to 2.8%. So, okay, we're getting there. There's more and more information that we have, less and less information that we don't have. And we also know that the market risk premium is equal to 6.75%. So technically, that's like everything that's highlighted here, there. So I'll take the time to just like highlight it. So it's everything right here. That's the market risk premium. But for now, whatever. And we also know that we have the beta of B. So we have one beta. So we don't have the beta of A nor the beta of B, but we have one beta. So what we could do is, well, you know what? If we have, at least for B, for asset B, in other words, for Apple, if we have all this information, why don't we go ahead and just solve for K for Apple? In other words, for asset B. Why don't we just go ahead and do that? Because it's definitely an unknown variable. And of course, ERA and ERB are still quite, they're quite far from us for now, but at least we could kind of work with that. And we're also going to assume that every asset is correctly priced, so that the CAPM holds, okay? In these types of questions, you just got to make that assumption. So step one is we're going to solve for the required rate of return of Apple, because we have the information that will allow us to do that. So I guess we'll use a random color. Step one. Solve for KB. Now, of course, at this point, this should be the gospel. So KB will be equal to the risk-free rate plus beta times the market risk premium minus RF. Now, in this case, once again, we do not know KB, but we know everything else. So it becomes a simple game of solving for the missing piece. We know that the risk-free rate is equal to 2.8%. We know that beta is equal to 1.17. We know that the market risk premium is equal to 6.75%. So that's awesome. Such that KB will be equal to following. Now, this is the first time that I've done this question, so I'm going to have to just actually solve for it too. So we're going to have 2.8 plus 1.17 times 6.75. And I like to always take a step back just to make sure that I've like placed in all the right inputs. So we know that RF is equal to 2.8. We know that beta is equal to 1.17. We know that the market risk premium is equal to 6.75. So far, so good. That's exactly what I placed into Symbolab. So we should be able to get the correct value. This is interesting. So if we zoom in a little bit just to like actually write the answer, we're going to get that the required rate of return on Apple's stock, so the required rate of return on security B or asset B is equal to 10.6975%. All right, so this is going to be KB. Now, assuming that CAPM holds, all right, so I'm going to write this here. If CAPM holds and prices are in equilibrium, KB will be equal to ERB. And this is a very, very powerful insight. It's very, I don't know why I got so excited, but like this is very cool because now a previous unknown becomes a known figure. It becomes a known variable just by solving for K. Now our ERB becomes something that we actually do know. And for that reason, we're now able to solve for ERA, the expected return on portfolio A. So I just feel like, let's go with the vibes and let's do it like with the vibes and do it step by step. And let's solve now for ERA. Sometimes I actually make myself cringe. I mean, most of the time, I'm not gonna lie. But as long as you get the information and that it helps you, I'll be happy. So let's go right for it. And let's do step 2, which is gonna be to solve for the expected return on portfolio A. I mean, on the asset A. So step 2, solve for ER. Okay. Very simple stuff. We know this by now that the return on a portfolio, if it has only 2 stocks, will be simply equal to the weighted average sum. So we're going to have weight of A times the expected return of A plus weight of B times the expected return of B. Now, of course, we're using this framework if and only if CAPM holds. So in this case, just to be super comprehensive, our unknown here remains to be ERA. Of course, we know the weight of A. Of course, we know the weight of B. Because of part 1 or step 1, we now know the ERB, so the expected return on portfolio on stock B. Sorry about that. So with that, we could compute for the return on portfolio. So we know that it was 60% invested in the essentially asset A, so into Meta platforms. And we know that by definition, it would have been 40% invested in Apple. And we know now that the return on Apple, if we just take a little step back, is 10.6975. 6975 is equal to 10. I'm so tired, my brain is not working. 6975. I'm so sorry, by the way, if I'm a little bit sluggish, a little bit less energy that I usually have. And I'm kind of like putting this excuse in every video at this point, but this is the 16th video that I've been doing in a row, no break, just because I really want to make sure that my summer students this semester have all of the information and all of the videos, like literally an abundance of material, such that they could really, rally for the final and do well. It really matters to me. So that's why I'm kind of torturing myself a little bit. I mean, I don't want to listen to you still. Anyways, I'm just tired. 10.6975. So we're just going to take a quick step back, and that's supposed to be, by the way, I just forgot to write ERP right here. If we take a step back, we know that ERP is equal to 15.28%. Sorry about that. And from that, we'll be able to solve for the expected return on portfolio A, on security A. So we're going to have 15.28. We're going to take a step back. So 15.28 is the expected return on a portfolio. That's going to be equal to 60% times this missing value, X, plus 40% times essentially 10.6975%. So we should be good. And we get to find that the return on stock, on Facebook stock, on essentially stock A, for security A, is going to be equal to 18.335. So this will be equal to 18.335%. Now, just to be super, super, super comprehensive, I'm just going to verify whether my answer makes sense, just such that we're not wasting our time moving forward. So we're going to have 18.325, and that should give us 28. Amazing. So that is actually the return on, well, the expected return on portfolio. I keep on saying portfolio, my bad, but on security A, on asset A. So now that we have that, we could actually do like a big move, okay? Because we know that this question is looking for the reward per unit of systematic risk for Meta Platforms Inc., we know that we don't need to like solve for like everything and anything. We know at the end, we're gonna look for beta A no matter what. That's really what we're solving for. So we could literally write this as beta of A. So if you remember this, and I'm gonna write it on the left-hand side here, okay, right here. If you remember, well, when we're looking at betas, we could actually kind of find individual betas simply by looking at the beta of a portfolio formula, okay? So I'm gonna write it up top, and I'm gonna give you the quick spiel that I give in every video. It's kind of hilarious at this point. But the beta of a portfolio is equal to essentially the weighted sum of its individual betas. So it'll look something like this. However, we could write this in a more human way. We could write it as simply being the beta of a portfolio is equal to the weight of A times the beta of A plus, the weight of B times the beta of B plus 3 little dots to highlight continuity towards forever, meaning that we would do the weight of C times the beta of C plus the weight of D times the beta of D, and so on and so forth. We could actually just highlight that by 3 little dots to kind of just like, like, dude, we're going to do that forever. All the way to the nth, all the way to infinity, all the way to the nth asset, such that we would have weight of the nth asset times the beta of the nth asset. So we could write it just like that. So we're going to make this easier for us because we know if we kind of just play the game of what we have and what we don't have, we know that we have ERA now. We know that we have pretty much everything. We also know that we have the weight of A, and we also know that we have the weight of B. And what's interesting, if you look at the formula, we also have the beta of B, such that, and you notice here that we're looking for the beta of A, such that, listen, our missing variable that really matters to us is right here. And there's actually a way for us to solve for the beta of B, a beta of like the portfolio pretty quickly. You know why? Well, because we have all of the information we need, right? We have the expected return on our portfolio. We have the risk-free rate. We have the market risk premium. So it becomes really simple for us to kind of work through this, okay? Now, once again, assuming that CAPM holds, really assuming that CAPM holds, we can actually move forward and make some pretty cool stuff with this, okay? So step 3 would be, step 2 and step 3 are kind of like interchangeable, but I just started with step 2 instead, but it's totally fine to do it in a different setup. So what I'll do though is I'm just gonna, I don't even know I can. Okay, so whatever. We'll write it on the side here. So step 3 in purple, solve for the beta of our portfolio, okay? So we're gonna just write this right here. So we're solving for the beta of our portfolio. Now we know this by now. We know that K is equal to the risk-free rate plus beta times ERM minus RF. So if we take a step back, we know a few things actually. We know what's the risk-free rate already. We know what's the expected return on the market and the risk-free rate, which in other words, we know what the market risk premium is. That's what I would try to more so say. So we know that for sure. And technically we know our K. Once again, if we take a step back, assuming that CAPM holds, right? This would also apply for our return on our portfolio. So I could even write this here. KP is equal to the expected return on the portfolio, such that we also know our K here. This really requires you to kind of psych yourself out a little bit. And then it becomes a game of solving for the beta of our portfolio. Okay? This becomes a really fun game. You just got to solve for that. So if we know that it's 15.28, right? So 15.28% is equal to 2.8% plus X times 6.5%, if I'm not mistaken, 6.75%. Okay. We know that the beta of the portfolio is equal to the following. So once again, we just got to solve for X. It's really a simple game. Okay. Solving for X. Now, of course, you know me by now. I like to always do a quick sense check to see that I have all the information that's needed to solve the question effectively. So let's do just that. Let me just plug my stuff in. So we know that the return on the portfolio is 15.28. We know that the risk-free rate is 2.8. We know that we're solving for X. We know that the market risk premium is 6.75. So 15.28 is the expected return on the portfolio. Risk-free rate is 2.8. X is what we're solving for, so the beta of our portfolio. 6.75 is the market risk premium. So we should be chilling. We should be chilling. And this tells us that the beta of our portfolio is equal to 1.8488888 until forever there. So what I'm going to do, I'm just going to zoom in and we're going to write that down. Sorry if it's like giving you like a seizure if I zoom in too quick, my bad. Not to make light of course, people who have seizures. Of course, that's not something that's fun. That's it's very not fun. I have friends who have that. But essentially, it's going to be like this. So this is going to be the beta of our portfolio. So now this is awesome. We're at the final stage. We can finally almost be over. Actually, no, we're at the before last stage. I guess I'll highlight this. Then so you really know that this is step 3. But yeah, so now this is awesome because we have the beta of our portfolio. And now it becomes a game of solving for the beta of our first asset, right? Asset A, which is Meta Platforms Inc. So we could go ahead and do this. We go ahead and zoom in and go to step 4. A lot of steps. I'm not going to lie. I'm not a big fan of this question. It's kind of long, but it's something that you may see on your exam. And all jokes aside, it's important to have that exposure just to really know, to dial in on the steps that would be required from you. So let's go. Step 4. Solve for the A. So you know that the beta of our portfolio will be equal to the weight of A times the beta of A plus the weight of B times the beta of B. Okay? And what's awesome here is that we have the beta of P, we have the weight of A, we have the weight of B, and we have the beta of B, such that the only thing that's missing is the beta of A. And yeah, we have the beta of the portfolio. Oh my God, I'm so sorry. Of our portfolio. That's 1.848. That's going to be equal to 0.6, so 60% times x plus 0.4 times 1.17. Then it becomes a game of solving for x, right? It becomes a game of solving for x. And now we're going to get the beta of a. Now, you know me at this point, I like taking a step back and making sure that we got everything we need to solve this question. So we know that the beta of our portfolio is 1.848 till forever there. We know that we're going to have 0.60 times, I guess, x. I gotta eat. I'm kind of hungry. I'm not gonna lie. 0.40 times 1.17. And I'm for sure going to take a step back just because I'm fairly tired a little bit. So we have the beta of our portfolio, which is going to be 1.848 periodic. And that's going to be equal to 60% times our missing beta plus 40% times 1.17, which is the beta of Apple. I feel like so far, so good. By the way, for sure, let me know if I made a mistake. I'm more than happy to make another video or correct it by, a proof or something of the sort. So let me just verify one more time. I'm a little bit tired, so okay, should make sense. So we know that the beta of Meta Platforms Inc. should be around 2.30148. That's awesome news. We can zoom in. Sorry if it's like a little bit too fast. So we're going to have this being equal to 2.30. I'll write this a little bit nicer than that. Sorry. 2.30148. That's going to be the beta of Meta Platforms Inc. But are we done yet? No, we're not. We're not done just yet. There's one more step that we gotta jump through. Okay, but it's still awesome because we found the beta of A, so we're pretty happy about that. Now that said, the last step is solving for the systematic return for a unit of the reward per unit of systematic risk. Okay, that's the last step. And right now I'm kind of brainstorming to find a nice place to write this at, but it seems like it's kind of going to be a hassle. So I guess I'm gonna write step 5 at the top. I'm sorry if it's a little bit crowded, but at least it's categorized, so you'll know where to look when you're doing this question. Okay. So let's go for it. I believe we're at step 5. And step 5, I'm going to go for black as my color. Black is beautiful. Step 5. Reward per unit. I'm just going to call it reward per. So all that you got to do is very easy. What you're going to do is this. You're going to do that, or I guess we're going to call it R, the reward. It's going to be equal to the expected return of A minus the risk-free rate over the beta A, such that the return, the reward, I guess, can be written as, now what is the return on A again? It was 18.335. So we know that we're going to have 18.335 minus 2.8. Now, of course, these are percents over our beta of 2.30148. 2.30148, such that our reward per unit of systematic risk will be equal to something awesome. Alrighty, so we can plug this in. So let's go for it. 18.55 minus 2.8 over 2.30. So let me just make sure we have all the right inputs. Should be good. So here we're telling you that for every unit of systematic risk, you're going to get 6.75%. And that's your answer. Okay. Now it took us an hour and a half to get there. I don't know how much time it took us, but it definitely took us some time, but we got there. And this is a very important question because it's definitely a curveball that they may send on your exam. So I'm gonna write answer here. %6.75%, and I guess I'll put it in a little box. Yeah, just like that. 6.75%. So we take a step back. I mean, listen, this question really does require you to be structured. And overall, I believe it's an amazing question to just build that like CAPM intuition, that portfolio theory intuition, because this is definitely a question that has appeared on past exams. And it's a curveball. You don't always see it, but you don't want to lose this free 5% or 6%. And hopefully by walking through this video and seeing the 5 steps that you would need to follow in order to solve this question kind of enlightens you. And hopefully you feel empowered. So I mean, I don't know how to say this, but I really hope this helped you out. It makes me extremely happy to perhaps give students a chance to feel like they can learn in a more human way. I'm going to stop my spiel there. You can find you can find a lot of more content on ismahelps.com, a bunch more content on my YouTube channel. And if you're not too sure, just write Isma Helps, online or on Facebook, and you'll find a bunch of resources. So hopefully this helped you out. Continue working hard, and like I really think you got this. Have a good one.